The spray bar test. Now that we've seen how to perform the spray bar test, let's talk about how we evaluate a water repellent unit. After 4 hours of elapsed time from the start of the water flow, we observe and record the measurements. For pinholes, we do this before the water is turned off. Pinholes have water trickles that are best observed while the water is still running. For hollow units, pinholes and dampness shall be evaluated on the inside the front face shell. For solid units, pinholes and dampness shall be evaluated on the back face. If we're going to record the test with photos, take these immediately prior to turning the water off. Immediately after turning the water off, observe and record the area of dampness on the surfaces. Utilize a grid sheet and count the number of squares over the dampness, and then divide the number of damp squares by the total number of squares on the sheet to get the percent dampness. Here's an example of a grid sheet that will go on the back face shell of your CMU block. After you've run the spray bar and you have dampness on the back of the face shell, you will get a shape potentially like this where the dampness is towards the bottom. Here we have a trace of where the dampness goes up the block, a couple of pinholes, and the overall grid sheet that takes up the whole back face shell. You'll see dampness is mostly on the bottom, and what you'll do is you'll count the number of squares that are in this trace marking, take the total number of squares in this damp area, divide it by the total number of squares in this grid sheet, which should never change, and you get your percent dampness. So this dampness we see is at the bottom of the back face shell. This typically occurs because of underfeeding at the machine. To repair this issue, you want to increase your feed time, increase your compaction time. This is because blocks are top is made, but bottom is laid. That's because, and you'll notice, the CMU, the webs, the thicker portion is what you have laid on top. But when you're producing, the thicker web is actually on bottom inside the mold. For example 2, here's a second grid sheet with dampness from the back of a face shell that's a little different. Here you can see the dampness extends quite high on the back of the CMU. In this case, there's clearly still integral admixture here, the water repellent admixture, but it's not very well dispersed. This could be poor mixing at the mixer, maybe not enough of the admixture was dosed, segregation occurred throughout production. We also noticed a few pinholes. This happens when there's a pathway from the face that is exposed to moisture, goes all the way through the face shell to the back where it could come pour out. These instances are more related to the blending of the materials, particle packing. Usually to get rid of these, you just pack a little longer, increase compaction. But when it comes to units where compaction is limited, like lightweight CMU, it's a little bit of a tricky zone because the more you compact, you raise the density. So if pinholes, there's a few troubleshooting steps to take in addition to the dampness that you see here overall. If you're experiencing any issues with water repellency block or have any questions to me or the technical services team at ACM, please give us a shout at any time. We're happy to help.